All right, my friends, this is going to be fun. Everybody thinks you got to be a rocket scientist to understand chemistry and atomic physics. You know, wow. No, this is not, get away from that feeling. Don't think somebody has to tell you something. You watch and then you make your own determination. I make things simple. And I'm going to show you right now how simple nucleophilic reactions are. And how that's the only reason you're breathing oxygen right now. Nucleophilic reactions are things that actually literally change the nucleus of an atom into something else, which they don't really understand it. And it's using enzymes, isotopes, and these different charges. Electron poor sites, electron rich sites. Well, what's an electron to them? Well, a little tiny thing hanging off of a big massive proton. No. It's a dipole. I'm going to show you what they are. They're just little bar magnets. Basically, that's all it is. And instead of being one big giant proton like that if you smash it, they say, oh, it goes into quarks and leptons and a particle zoo. Yeah, because it's actually made out of that. And that, my friends, is about 1,839 particles instead of that. When they smash that, they just have debris. They can look at it for 10 years. They still can't figure out what it is. We smashed this. Right there. That's what we used. So we don't damage the CMOS in the detector, because it's just a smartphone. Now CERN is also doing that. They're using the same technology we used 10 years ago, 12 years ago, or more. So that's what I have to show you. Do not freak out. This is simple, and you'll understand more than well, you'll understand a lot. Let's put it that way. Because I haven't found anybody in the expert realm that will address this. Nucleophilic substitution and invasion is how we live. That's how it happens all the time. And when you die, it still tries to invade, but then it gets in there and it can't get out. All right, and it depends on what the chemistry is and the water flow and so forth. When these creatures were preserved, what kind of things get stuck in there? Because they want to invade just like they normally do. Usually they come and a bunch of stuff leaves. You see it, there's an invading partner and a leaving group. All right? Displacement of a leaving group. They come in and they just throw the other guys out. Well, when you're dead, you can't just continue to do that process. So what happens is you've got to stop there somewhere. These blood metals want to find a home. And that's why you have all these different colors in the mud fossils, and especially in opals. Opals come out of Australia. I just did one on Australia. It's just nothing more than solid blood, basically. And the opals that come out are unbelievable. However, they were formed within a literal ball of blood. And that's what makes them so spectacular. And there are certain regions where it's more dense blood, or the conditions were just right to make in the Yoa region, they call it. And they call them Yoa nuts. Well, they're not nuts. They are organs. I'll show you one right now. All right, you see all these different transition metals? And there is a ton of them, not just these. And they have all these different charges. Primarily, they're in this section right here, transition metals. And then you have some metalloids. And there's other things that are in your blood. There's all kinds of, your blood transfers everything in through your body. That's the only place you get your stuff from, is from your blood. So it has to have everything. And the way it transfers things, though, is through these charges. All right? These charges hold on to what they call ligands. These are attached molecules to this metal core. See the M plus here? That's all these metals. Metal with the plus charge. That's how nucleophilic invasion and substitution happens due to pairing. Well, hold on. All right, this is confusing, but don't worry about it. It's what it happens is some new molecule comes in there and takes over that site and pushes the old guy out. Nucleophilic reactions occur because an electron-rich site, species like this, has extra electrons, which is the nucleophile. It's a killer of the nucleus, is attracted to and attacks an electron-poor site, which is the electrophile, on another molecule. All right, so it attacks it like this. Well, then what happens? Well, what's going to happen is it's going to drive a chunk off, and it's going to make a new type of molecule. And this is all done by enzymes. They don't just break apart and fall apart for nothing. You've got these attracting molecules that have these charges on them, but all of this stuff works with enzymes. You can't use all these particles without an enzyme interacting with them. They don't just, in my mind, they just don't happen for nothing. The enzyme continues to work away at these things to bring them back to stability, basically. That's what enzymes do. They break things down and build things up. Now, this is the key, and I don't think they understand this well yet. These little balls here are what are called ribosomes. They're little balls made by bacteria. They come out, and when they get triggered, they unsheath. So they come out like this, and then they unsheath, and they go into a huge polymer like this, huge. Now, enzymes are bigger, and they break down particles. They break down your food. They're killers. They're destroyers. Enzymes are the things that break down the particles so that they can be used as proteins by other ribosomes. Hold on. Okay, a little technical issue there is now. You see how uncomplicated a protein is compared to an enzyme? Enzymes do millions, literally millions of years of chemistry in 1 second. An enzyme, because they got to break things down. They got to do half-lives. And a half-life sometimes take 100,000 years, and another 100,000, another 100,000. This is a blip done. That fast. And the same thing with the proteins. These make the building blocks for life. You have bones and muscles and teeth and eyeballs and all that. These break down the foods and do all that stuff. I think I already said that. These little balls are so tiny that you could have millions of those, literally millions, in a single human cell. One human cell could have millions of these that come out to be so exotic they look like this when they open up. When they're just a ball, they're almost nothing. When they open up, this is what happens. When they come in as a ball, there's almost nothing there. I don't know how it does it, but all of a sudden it goes bloop, and there you got it. Something triggers them, and they're very specific for the trigger. So they don't just happen to pop in and here and there. They need to be tickled, triggered, and then they do what they do. And like I say, there's millions, or at least 1 million or more, in every single human cell. So when that cell tries to get invaded, these things kick into action. Or when that cell needs to have chemistry done, these kick into action. Or when whatever biology needs to be done, it requires a catalyst, which is an enzyme, and they come from bacteria. All right, this is very simple. I showed you the ribosomes, those little tiny things. They come out of bacteria, which are also little tiny. All this stuff resides in the lymph fluids of your body, which is the immune system. It's the fluid-filled highway. I've been talking about this for 10 years now. As long as these are in good shape, because you have good bacteria, you're in good shape. they're going to do their job in that layer, which will protect you, and also in your gut, which will break down your foods. Now, let's take the break down the foods ones. That's these. They squirt out these ribosomes in your gut, all in your stomach. Well, not your stomach. Well, yeah, or everywhere down and through your digestive system, from your everywhere, all the way down. And they create the bacteria that live there, create these ribosomes. They attack the foods. They do all this certain stuff. Now, whether they all exist there at the same time, or whether they actually turn these on when you have a carrot instead of a corn or whatever, I'm not sure of that, but I do know they sort out these ribosomes, which break down the food. So let's get away from that side of the bacteria. These are the killers, and they also carry the stuff away. They'll come up and eat up all the bad stuff in your body, bring it over the lymph nodes and drop it off. Now, there's another set that make you immune. They're ones, and they can make you sick too. They're the ones that create programs. These have a program built into them. They know what they got to do. They break down a carrot. I break down corn. I break down fats, acids, salts, sugars. I deal with whatever comes to me as a chemistry set. The other one says, I am a chemist. I am a pharmacist. I will kill and destroy the invaders. Or I am an invader and I'm taking over. All right, here's what happens when you get immune to something. If your body creates it by itself. Now, they're trying to put in this mRNA automatically without having the bacteria do it. The way it should work is the bacteria in your body create a ribosome, which I just talked to you about, which is the chain of these polypeptide balls, basically, which are the amino acids, and there's 20 of them. I believe there's 20. And they come in here and they literally program an mRNA strain, which goes through your body and connects using uracil into the DNA double helix. It uses transferase here, which is an enzyme. You see this cloud, that means it's an enzyme. It's doing an amazing amount of work instantaneously. This also is an enzyme. Anytime you see the A's on the end, this is RNA polymerase. It's blending that stuff into your DNA, and now you're immune from whatever, smallpox or measles or whatever. Now, the issue with vaccines and so forth, in my opinion, is that they're giving you, forget all this stuff, they're giving you right from here into your body. So there's none of you is making this. Normally you make this. So they're starting here, squirt. Now that goes into your DNA. Now what happens then? Your body says, hey, that's not supposed to be here. This is a problem. And it sends down a repair kit to fix that and get it out of there. When it does, it says, hey, remember this thing. That thing, it's a good thing we got that thing in time. Remember that thing. So now you are immune to, if it comes back again and says, oh, I know who he is, send down Hank and Bobby and the rest of the guys and take care of it. Done. Oh, done. That's immunity. Now, the program they put into you, that's the key. Is that program exactly correct? Well, I'm not going to make a determination one way or the other, but I can tell you what, even if it isn't right, if your body is capable of fighting back against even the things that aren't right, because just about anything can invade you, it will fix those things and stop them.